Hey there, Seahawks, it's Miss Adams, and in this video we're going to talk about measures of spread. Alright, range takes the largest number in our data set and subtracts the smallest number in the set to give us the difference between these two extremes. The larger the range, the more spread out the data is. Alright, find the range. The sample of starting salaries in thousands of dollars is given below. Okay, so the range would be the highest value minus the smallest value. So I need to first identify the smallest and the largest values, which I've done. So I'm going to take my maximum, which is 47,000 minus 37,000, and that gives me 10. Okay, I want to put this in context. So the sample has a range of $10,000. All right, the interquartile range doesn't consider extreme values or your outliers. The IQR looks at the range of the middle 50% of the data. All right, so the IQR is really great if you know you have outliers that are kind of skewing things. This just kind of looks at the middle 50%. So find the interquartile range of using the same data that we had from above. So first we need to put the data in order from least to greatest. And the interquartile range, it takes the middle number of the upper half minus the middle number of the lower half. So first I have to figure out where's the halfway point. All right, so I put a dotted line right through the middle. So I had 10 numbers. So right in between the fifth and sixth number, I divided the numbers, the data set, in half. Now I'm going to look at the one side, and the middle number on the lower side would give me quartile 1 or Q1. And then the middle number on the upper side would give me quartile 3 or Q3. All right, and to find the interquartile range, the IQR, I do Q3 minus Q1. So it'd be 44 minus 39, which gives me 5. All right, so the interquartile range would be $5,000 if I put it in context. Variance is the average of the squared differences from the mean. A small variance indicates that the data points tend to be very close to the mean and each other. One problem with the variance is that it does not have the same units of measure as the original data. So this is why we use the standard deviation, which is the square root of the variance, and that brings it back so that it's the same units of measure that I was using originally. The standard deviation is the average amount we expect a point to vary or deviate from the mean. Okay, so on average, how far are the values from the mean? This is the square root of the variance, and there's two formulas. If it's a sample standard deviation, if all the numbers are coming from a sample of a piece of the population, then it's the sum of your value minus the mean quantity squared divided by n minus 1, and n would be like the number of numbers in your set. If it's coming from the population, like you know every single value, it's the sum of your values minus mu, which is the mean, squared, divided by n, the total for your set. All right, we're going to mostly use the sample standard deviation formula. All right, so for this one, we're going to find the standard deviation using the data that we had already used. So here's that data in order from least to greatest again. And I'm going to make a table. You probably don't need to write out all of these values from this table, but follow along and write out at least the differences and the squared differences and then the sum. All right, so find the mean. I went ahead and added them all up and divided by how many numbers I had, and that gave me 41.5. So I'm going to take my value. My first value was 37, and I'm going to subtract the mean, 41.5, and that gives me a difference of negative 4.5. Then I'm going to square that difference so that I don't have any negative values. And that gives me 20.25. And I'm going to move to the next one. 38 minus the mean, 41.5, gives me a difference of negative 3.5. When I square it, I get 12.25. Move to the next one. 39 minus the mean gives me a difference. Square that difference. Move to the next one. Subtract the mean from each value. Get the difference. Square the difference. All right, I'm going to keep doing this until I have all my numbers. So I had my last one was 47. I subtracted the mean. That gave me a difference of 5.5. I squared that. That gave me a difference squared of 30.25. So now I found the deviation. The deviation would be like the difference. I squared the deviations, add up all the deviations. So I'm going to add up 20.25 plus 12.25 plus 6.25 plus 0.25 plus 0.25 plus 0.25 plus 0.25 plus 6.25 plus 12.25 plus 30.25, and that gives me 88.5. And then I'm going to take that value and divide by n minus 1 and take the square root. Well, I had 10 values, so n minus 1 would be 9. And then I get 9.833. And I'm going to take the square root. 9.833 would be the variance. If I want the standard deviation, I take the square root of the variance, and I get 3.136. All right, so some symbols for variance and standard deviation. Your symbols are different depending on if you're talking about the population parameters or the sample statistics. Okay, and you want to be careful with the symbols that you're using, especially if it's something that is like written out. Okay, so they have different meanings. Mu, the Greek letter mu, stands for the mean of the population. X bar is the sample mean. Sigma squared is the variance for the population. S squared is the sample variance. Sigma is the population standard deviation. S is the sample standard deviation. Capital N is the number of entries for a population. Lowercase n is the number of entries for a sample. X minus mu is the deviation, your value minus the mean. X minus x bar is the sample deviation. And then the sum of squares would just be you squared those deviations and the summation symbol. All right, when to use each measure of spread. If a distribution is symmetric or approximately normal, you're going to use the standard deviation. If it is skewed left or skewed right with outliers, any of those things, then you want to use the interquartile range. All right, the standard deviation on your calculator. So if you're using a graphing calculator, if you're using the TI 84, 83, 84 plus, you're going to go to Stat, Edit, and then you're going to enter all your data into List 1. Then you're going to go to Stat, and you're going to go over to Calc, and you're going to click 1 var stats, which is 1 variable statistics, and you're going to use List 1 and go down to Calculate. Then you'll calculate it by hitting Enter, Enter, and you use SX in your calculator for the standard deviation. It also gives you a bunch of other information. All right, so in your calculator, to find the standard deviation, we're going to go to Stat, Edit is already highlighted, hit Enter. If you have anything in List 1, you can go up to the top and hit List 1, hit Clear, and then Enter, and it'll get rid of anything that you have in List 1. Don't hit Delete. If you hit Delete, it'll get rid of List 1. You have to reset your calculator. All right, so then we're going to enter in our data. So we have 1, 3, 4, 6, 7, 8, 9, 10, 12, 13, and 15. So once you have your data in, we're going to go back to Stat. We're going to go over to Calc, and we're picking this 1 var stats option, so Enter. I'm using the data from List 1. If you put it into another list, you have to change the list that you have. So if you put it in List 2, you hit Second 2, and that'll change that to List 2. Or if you put it in List 3, Second 3. And then we're going to leave frequency list alone. We're going to go to Calculate. And I'm going to hit Enter, and I get all of this information. So X bar is my mean. I'm not worried about this. SX here is my standard deviation. If it's a sample, sigma X is my standard deviation if it's coming from a population. N is the number of entries, which is 14. And if you go down, you get your minimum, quartile 1, median, quartile 3, and your maximum. So this piece here, this is your 5-number summary. You can use quartile 3 and quartile 1 to find the interquartile range. You can use min and max to find the range, and you have all of that information there without having to do a whole lot of work. So after you put this into your calculator and you get everything to pop up, you pull off the mean, the standard deviation, the range, which is your maximum minus your minimum, the interquartile range, which is quartile 3 minus quartile 1, and this is what you should end up with. All right, so I want you to try this next one. So again, you're going to enter the data into your calculator, stat edit, then you're going to go to stat calc, 1var stats, and get this information. And you should end up with these as your results. All right, go Seahawks.